So, we're going to take a look at this frame for congruent triangles and transformations. So make sure that you've got that paper for the frame that looks like the one that you should have gotten, the handed out one with triangles on one side and some graphs on the other side. And we are going to take a look at these. So make sure you're following along. If you're not done, ask the substitute to pause it long enough so you can get this stuff copied down, because this is what you'll be able to use on the test, so it's a pretty big deal to get it done. Alright, so the first side is this side. This is the side you want to have out. Okay? So, let's zoom in so we can see better. So our key topic here is congruent triangles. Okay? We are going to use the rules to determine which triangles are congruent, and then we're going to use that rule to state why, essentially. Okay? That's kind of what we're coming down with. So, if we're looking at this, we've got four main rules. Okay? Let's zoom it so we can see all three of them, or four of them. Wow. I teach math, by the way, but can't count. Anywho. Alright. So we've got four rules that we take a look at. We've got side, 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 hence the side, 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 angle, side, side, angle, and angle, angle, side. Now, you may look at these two and say, aren't they the exact same thing? And it's not. The order does matter in what you do them, okay? So like a triangle, an angle, and an angle, okay? There's two angles. Well, where's that side? That side's in between. The only side in between those two angles is that one. Whereas if you're looking at these two, the side that's not in between is either this one or this one. So that order does matter for us, okay? That order does matter. So we're going to take a look at this. So if you haven't written this first little bit down, okay, make sure that you get it paused so you can get it down. Alright, we're going to zoom in now to just one of these at a time. So, side, side, side rule. Okay, basically it states this. If the three corresponding sides are congruent, then the triangles are congruent. Okay, remember the whole point of these rules is so that we don't have to always know exactly are all three angles, are all three sides gonna give us a congruent triangle. So it's that shortcut that we're looking at to kind of be lazier, so we only have to know some of the information. And the three sides together, they lock it into a position. So if you have two triangles with congruent sides, that's what you're gonna get. Now remember, corresponding is the pieces in the same position. So like A and E are corresponding. They're in the same position in the name and in the triangle. B and D are. And F and C. Okay? So when we write that congruency statement, remember, the corresponding parts have to be in the same order. And we use that little symbol, the equal sign with the 2 That's our congruency sign. So if I give you two triangles and they have three corresponding congruent sides, then yes, we can call them congruent. We've got one side, two sides, three sides. So yes, they are congruent and possibly mean. Okay? So that's all there is to the side, side, side. So when you see the two triangles and they have three congruent sides, you know right off the bat they're congruent because of side, side, side. And that's really what it comes down to. Okay? So if we take a look at this next one. There we go. Side, angle, side. Now, once again, the order matters. So it's two sides and the included angle. Okay? The included angle, if I think of two sides, is always the angle that connects the two sides. So if it's this side and this side, this is the angle. Okay? If it's this side and this side, this is the angle. So it's always those included angles with the sides. Okay? Very important that we have that distinction. So if two sides and the included angle are congruent, then the triangles are congruent. Okay, so here's two more triangles. Notice we've got the two sides and the included angle. Okay? It's got to be that angle. If it's this angle, it won't work. If it's this angle, it won't work. It's got to be the angle in between. Now, could it be two different sides in the angles? Yeah, that's true. If it were this side and this side, it would have to be that angle. Okay? If it were this side and this side, it would have to be this angle. Or if it's the two that we already have up there, then it's that included angle. So it's a side, an angle, and a side. Okay? Connected like that. If we have that situation, then we know they're congruent. Okay? So, let's take a look at this. Okay, angle, side, angle. So now we've got two angles with the side in between. So if two angles and the included side are congruent, then the triangles are congruent. Once again, if you didn't get all this stuff written down, make sure that you're asking to go back or to pause so that you can do that. So now we've got the two angles here. And the side has to be in between. Not that side, not that side. It's got to be the side in between the two angles. The one side that's touching both angles, essentially. If you've got that situation, then yes, they're congruent, and you can write your congruency statement on the triangles. Okay? It's as simple as that. So it's kind of more of just knowing how to see these four, having these out with this frame out when you're working on the homework, when you're getting ready for the test, and looking to see which one it falls into, which category. Okay? So, the last one is the angle side one. So it's kind of like this one. If you have two angles and one side, pretty much it's going to have to be a congruent triangle. But notice the different positioning now of the side. Now the side is not in between there. It's not this one, because that's side, angle, side. So if two angles and one side are congruent, then the triangles are congruent. Okay? And you can write your congruency statement. So make sure you get those down, and then you can take a look at things. Now there is one rule, one side that does not work. Okay, that's the side angle rule. If I have two triangles, and if we got to the calculator portion of this part, you got to see it. But if I've got two sides and the opposite angle, an angle that's not in between them, that one will not work. Okay, it will not lock it into place. That one is not a rule. You can never use it. Okay, can't ever use it. Alrighty, so that's the one side of the frame. So if you didn't get any of that, ask to rewind it and get it so you can have that ready for the homework and everything. Because if you have that with you, it makes this really pretty simple. Okay, so the back side, just a little bit to talk a little bit about those rigid motion, those transformations. Okay, that's what we're going to talk about next. Alright, so the transformations. So the first transformation is the translation. Okay, and the translation, remember, is just sliding it around. So it doesn't rotate it, it doesn't reflect it, it just slides it around. Okay, so you just move it on the graph. Remember, we can write those rules, x comma y. Well, if we add 7 to x and we move all of these to the right, 7. Okay, and then if we subtract 12 from y, that's a y. Then we move down, each piece down 12. Okay, and we get our image. Remember, where it ends up is called the image. And they use those little apostrophes, and they call it, triangle A prime, B prime, C prime, as opposed to the pre-image, which just has the regular stuff going on. So you can do lots of different types of translations, and those rules can help you understand that. So we could go xy to x minus 5, comma, y plus 2. So now we'd move every point to the left 5. So 1, 2, 3, 4, 5, and then up to 1, 2 would go right there. And 1, 2, 3, 4, 5, 1, 2 right there. 1, 2, 3, 4, 5, 1, 2. It's kind of like you're taking the slope. Remember, slope is y over x, and you're applying the slope for the y and for the x for each point separately. Okay, so there's the slides. Not too bad to deal with. Most people get that pretty well. The reflections are when we take that mirror image. Okay, so let's take a look, and I tried to put a lot of information on one. So we can do it over the x-axis, over the y-axis, over the horizontal, the vertical, or a diagonal line. So if it's over the x-axis, we start here with our triangle right there. Basically, the x's stay the same and the y values just turn opposite, from positive to negative or negative to positive. So that's one way to think about it. The other way is to notice the x-axis is right here. Well, how far away is each point? It's 1 away, and we're not moving it other than that vertical, so we put it down 1 away. This one's 2 away from the x-axis, so it goes down 2, and we get our new triangle. So that's with the x-axis. With the y-axis, across the y-axis, the y values stay the same, but the x values become opposite. So instead of a positive 4, we go to negative 4, negative 1. Instead of a positive 6, it's a negative 6. And we can get our triangles that way as well. Okay? Or you can think of it as this point is 1, 2, 3, 4 away, so we move 1, 2, 3, 4. Okay? Those are the easy ones. Now, if I just give you a line, like say we've got this line x equals negative 3, so you've got this vertical line here. Okay, that rule application really doesn't help in this case. In this case, you just think, well, how far away is it? It's a vertical line, so I know it's just moving horizontally. Okay, so that point right there is 1 away from my line, so I just go the opposite direction 1. This one's 3 away, so I go in the opposite direction 3. Same with that one. Okay, and similarly, if it's over a horizontal line, it's the same concept. Like this one, y equals 2, you're just doing it with that vertical. How far away from your line is it? It's 3, so I've got to go up 3. It's 3, so up 3. 4, so up 4. And I get my new triangle. The toughest ones to deal with are when they're diagonal lines. Okay, those are the hardest to deal with. So like this one. So we've got this diagonal line right here. The best way, and I'm not going to give you any of those lines that are more difficult than this, okay? So the way to think about this is this diagonal line is pretty simple. So you're just going, how far up am I going? And then I'm going to translate that to across. So I go up 1, 2, 3. So I move 1, 2, 3 over and draw my point. To the left, 2 takes me to mine, so I go up 2 to get it. Same with this one, to the left and up. You're kind of making a box around it. Okay? And I won't give you any lines that have a slope that's harder than that. Okay? So there's our reflections. Okay. Now we want to take a look at our rotations. So let me clear that off. Let's take a look at these rotations. So remember, rotation is just spinning it around the graph. And if we think about that graph, okay, 90 would be spinning at one quadrant. Each quadrant is like 90 degrees. So if I spin it, whether it's counterclockwise or clockwise, okay, one quadrant will move it to the next one. If it's 180, it'll move it across. If it's 270, it'll move it 3. Okay, so that's kind of what we're thinking. Now, we came up with some rules about some of these. So let me pull those up. Okay, so those rules we came up with was a rotation of a 90-degree counterclockwise, which, if you think about it, a 90 degrees counterclockwise, isn't that the same as a 270 clockwise, where we swap the x and the y? So 270 counterclockwise is the same as a 90 clockwise. So honestly, I would write these down on the side of your paper somewhere. Okay? And a 180 doesn't matter if it's clockwise or counterclockwise, same thing happens. Okay? So we just use the opposite when it has that negative in front. So if it's positive, changes to negative, negative to positive, and you change the x and the y. Okay, so pause it if you need to. If not, we'll move on and take a look at this. Alrighty. So let's see what it kind of looks like. Okay. So if we start out here, you can use those rules to, like this C. The C has positive 5, positive 4. Well, if I'm just going 90, well, the 4 and the 5 change, and the 5 becomes negative. Okay, if we go clockwise like that. And so then we'd go, positive 5 down to a negative, or sorry, this is the change, right? Positive 4 down to negative 5, and that's C prime. So you can do that to all the points. The other way to think through it is to just kind of a 90-degree rotation. This is my x value, this is my y value. Well, I rotate this 90 degrees, this is now my y value, and this is my x value. And that's basically what those rules state, but that's just kind of a more visual way of thinking. So when you rotate 90 clockwise, or I guess 270 counterclockwise, that rule you can use to switch it out. Okay, 180, you basically take those points and just make them the opposite. So if they're both all positive, they end up all being negative. All negative, positive. One positive, one negative, the other negative, the other positive. Okay, it doesn't matter where you are, that 180 will give you that. Okay, and then finally, the last one, a 270, which would be a 90 counterclockwise. Same idea, just switch them. The only difference is the y's go from negative to positive. Well, sorry, this way. The y's stay positive, the x's change. Okay, so there's our frame. If you needed any more of that, please go back to the portion you missed. You can also go at home and watch this same video if you missed any pieces. Okay, so that's our frame. Make sure you guys have it. You can use it on quizzes, tests, all that good stuff. So get that frame. Okay, same with this one. Get that frame completed. Alright, so let's take a look at how we deal with these congruent triangles and how we look at them. This is not your homework. You'll get your homework after this. This is just going over how we do it. So you could ask the substitute to get your homework out so you can look at your homework as we're going. That's fine by me. So the first thing, state if the two triangles are congruent, and if they are, tell us how we know. So our choices are side, 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 angle, angle, or angle, angle, side. Those are the four choices, or I guess not congruent would be the fifth choice. So a few things to notice. If you ever have two triangles that share a side, that side is congruent with itself, meaning that counts. So I've got one side, two sides, three sides. So yes, they're congruent because they've got the three sides, side, side, side. Number two, that one's pretty easy, right? 1, 2, 3 sides. So yes, by side, side, side. Okay. Now look at number 3. I've got an angle here and a side here, and they share another side, right? So side, angle, side. Okay. Whenever they share a side, you count those ones. So that would be yes, side, angle, side. Okay, what about number 4? Now, if you see an angle like this, that's basically forming an X. The sides opposite, the angles opposite, I shouldn't say side, the side, angles opposite are congruent. So those two would be congruent, and these two would be congruent. So if I'm looking at that, that gives me a congruent side, or angle. So I've got an angle and two sides. So some of you may say, oh, that's angle, side, angle, or angle, side, angle. Okay, angle, angle, side, or angle, side, angle. Do I need to say it a third time? Angle, side, angle, or angle, angle, side. But look at the position. Is that angle in between the two sides? No, so it takes that one out. There's only one side, whoa. I'm getting confused now. Oh crap, I forgot that's going to erase it all here. Let's go back like this. There's actually two sides and an angle, so we can't use those ones, so scratch that out. So is it side, angle, side? Well, is that angle in between the two sides? No, it would have to be this angle. Okay, so that one's the one that doesn't work, the side, side, angle, so they're not congruent after all that fun work. Okay, alright, let's take a look at some more now. Okay, so they share a side. So we've got a side, three sides. So yes, by side, side, side. Look at number 6. They've got an angle, a side, and an angle for these two triangles. Not enough information, so we have to say not congruent. Okay, look at number 7. They share that angle right here, so we've got an angle, and a side. So yes, by angle, angle, side. Those ones work. Okay. Look at number 8. So those two angles would both be right angles, so they're congruent. Right angles are congruent with each other. So we've got two angles. Do we have the side in between? Nope. Do we have a side outside? Yes. So that one does work. It's yes by angle, angle, side. Okay, number 9. We've got, it's basically the same thing as that. There's a lot of side, side, sides here. Thought I'd set it up so there wasn't, but yes by side, side, side. They share a side. Okay, number 10. We've got that angle that they share, so a side, an angle, and a side. So we'd call it yes by side, angle, side, because we've got the two sides and the angle in between, so that one works. Alright, let's take a look at some more. So if we look at more of these, 11. Two right angles, so they're congruent. Two other angles that are congruent, and they share a side. So we've got an angle, and then a side in between. So it's yes. Okay, number 12. An angle and a side. There is no angle side or side angle. So we would say not congruent. Okay. 13. Okay, on 13, we've got an angle that's true and a side, but not enough information, so not congruent. Okay, we look at 14. We've got an angle right here that would be congruent, so an angle, and a side. Two angles and a side off to the side, that works, so yes. Number 15. So we look at this one, we've got two angles, because that would be a right angle also because they're opposite each other. Two sides, and the angle's in between, so two sides with an angle in between. So yes by side, angle, side. 16, we've got this side they share, the other two sides, so yes by side, side, side. Alright, the other type of problem you're going to see is where it tells you a reason and it wants you to figure out what other information we need. So 11, we got three sides. We've got one side here, one side they share. So what else do we need to know? We need to know these other two sides. So we have to know that EK is congruent to ED. That's what it wants you to tell me. So 12, we've got two angles and a side. Well, I've got a side, and I've got an angle. So, an angle and a side, so we need another angle. So it doesn't matter which one we choose. We could do this one or this one. Now, some of you would just say angle H has to be congruent to angle I. The problem is, that's talking about the big angles. There's two ways to name angles. One is just by using the vertex point. The other is by using the 3 points. So this is a vertex, so I use I and V. So VHI would be that angle, and GIH would be the other one. That would be more precise. Okay, 13. Angle, side, and angle. So we've got an angle here and a side here, so which angle does it have to be? If you choose these ones, that's wrong. That's angle, angle side. We want angle, side, angle. So it's got to be the other angle that touches that side. So it would have to be angle M has to be congruent to angle E. That one, it does matter. Okay, same with 14. We've got two sides, so we need an angle. Well, if you choose this angle, that's great, but that's not side, angle, side. Okay, that's side, side, angle. Doesn't work. Same with if you try to use these two. Doesn't work. So it's got to be the two angles that are, it's got to be the two angles that are in between. So angle E has to be congruent to angle R. Alright, so there we go, guys. That's pretty much all we needed to talk about. So, get that homework, get it done, and then we can talk over any more questions that you have. So, we will see you guys later. And he's waving. It's like little wave lines. He's moving his hands. Alright. Good luck. Get that homework done. You should have plenty of time to work on it. If you need any more help, get it.